Hi, I'm Chirag, and in this video I shall present our work on dynamic expression-based wrinkles for synthetic faces, done jointly with Charlie, Errol and Tadas from Microsoft Cambridge. Synthetic training data has shown promise for face-related vision tasks. So a natural question arises. Is the pursuit of photorealism excessive? In this work, we show otherwise. We boost the realism of our synthetic faces by introducing dynamic skin wrinkles in response to facial expressions and observe performance improvements in downstream computer vision tasks. We build upon the face synthesis pipeline proposed by Wood et al. And begin with the observation that all expressions share the textures corresponding to the neutral expressions. For every identity, we capture complex wrinkling effects corresponding to the expanded and compressed deformations of the face from scans of the identity's posed expressions. We store these wrinkling effects in textures known as wrinkle maps. At synthesis, we blend between the neutral and wrinkled textures using the tension at each vertex in the face mesh as weights, producing the final dynamic wrinkling effect. Using tension in the mesh for blending between textures also enables us to produce wrinkles for expressions not present in the source scans. We formalize mesh tension to capture the amount of compression or expansion at each vertex of a 3D polygon mesh resulting from a deformation. Specifically, we express tension as a function of the mean change in the length of the edges connected to a vertex as a result of the deformation. To obtain the wrinkle maps for an identity, we begin by computing tension maps for each expression scan. We use these tension values as weights to linearly combine the textures across expressions to obtain the expanded and compressed texture maps. For the same expression parameters, our method produces varied wrinkling effects across distinct identities. Moreover, for identities without expression scans, we compute wrinkle maps by grafting wrinkles from the textures of those identities with the most similar neutral textures. On the task of keypoint localization, we find that synthetic training data with dynamic wrinkles is especially useful for compressed expressions. To evaluate model performance on these expressions, we introduce a novel 300W winks and the Pexels winks and blinks datasets. Through ablation studies, we also find that displacement wrinkle maps are critical for achieving realistic lighting of wrinkles. For the task of surface normal estimation, models trained on synthetic faces with wrinkles recover significantly more high-frequency details. Moreover, we yield predictions comparable to state-of-the-art methods trained on real-world data while being less noisy and more robust to lighting. Thanks for your attention. And more details can be found on the project website.